Hello, this is Trevor Lewis from the Voyager Middle School STEAM Lab, and today we're going to be talking about variables in coding. So you may be familiar with variables because we've used them before in math class. So a variable in math class has a certain form. It's usually x or y, and we are used to using it in equations like 5x plus 2 equals 12. And in this case, x is something, we just don't know what it is. It's holding the place of a number, and we can find it, but it's on this one value, this unknown number. But more likely, what we do in computer science is similar to what we do in math class when we have an expression. So instead of 5x equals something, let's do something a little more complicated. 550 times x plus 350. Maybe this is an expression that is the cost of something that has a shipping fee of $3.50, and it costs $5.50 per x. So we can try different values of x. So for x equals 1, for example, we do the math, we put in 1 times 550 plus 350 equals 9. And if we wanted to try x equals to 3 instead, it's going to be more. It's going to be 20 this time. So this is a form that allows us to do work. And once we figure out this algebraic form, the computer does the math for us. So that's what we use in coding. In coding, the first thing that's different is we need to name our variables differently. When we name our variables, what we're going to do is we're going to always choose a name that makes sense for the quantity we're trying to represent. So the variable needs to say what the number is, or what the thing that we're containing in the variable is, because it's not always a number. And when we are writing out these variables, we want to use lowercase. We want to have no spaces, because if you're typing out a written language, those spaces would be a different command. You can use underscores if you need to split into two words, or you can use camel case. Camel case is when you put a capital letter in the middle, like the hump of a camel. So when we're working with variables like this, let's get some examples. There are a lot of numbers that you need to keep track of when you're coding, so you might want to keep track of something like the score. So that would be a good variable name. You could have the height. The height could be where something is on the y-axis, or it could be how tall a sprite is or something. You often talk about size, but if we want to get more specific, maybe I want the size of a particular square. I'd call that square size. Here it is in camel case. And this is what it would be if you used an underscore. Okay, so now that we know how to name the variable, the way we think about it is different too. The way we think about variables is variables are like a bucket. They're like a bucket because they can hold something. They can remember something. Without this, the numbers that go through your code are just passing fads, and your code won't remember them. So if you want your code to remember something like a number, you got to have a variable. And remember, we need to name our variables. So let's make sure we label our bucket, because eventually we're going to have a bunch of these, and we got to know which one's which. So if we have this bucket, it's called time. Maybe we store a time in it. And maybe this is the timer that we use in our game. So let's put 16 in it first. So that's one of the first things we can do with variables. So one of the first things we can do is set the variable. So it doesn't matter what was in the bucket before. We dump everything out and we just throw 60 in. Now we know 60 is in there. We set time to 60. The next thing we can do with a variable is we can change it. So when we change a variable, it matters what's already in there. So if we have 60 in there and we put one more in, now we have 61. If we put two more in, we have 62. If we had nothing in the bucket, however, now we have 2. So it really matters what's in there. We can put things in, like +2. We can take things out, like -1, and it will change the amount that's in there. The next thing we can do is we can check what's in the bucket. So once we have that number in there, it doesn't really do us any good unless we can look in. So if we look in the bucket, we can see what's in there and maybe make a decision. Maybe if the timer is equal to 0, when I look in the bucket and I see that the timer equals 0, I can say game over. The last thing we can do is we can use what's in there. So we can take whatever number that is and we can just insert that into our code. So maybe this doesn't make sense for the time, but for the square size one, we can actually use that in our code to set the size of the square. So we'd move that number of steps. Let's do an example. So let's write some code. So you can see in what this code does is it draws a line that's 10, then 20, then 30. And you can sort of see the pattern that's emerging here. If I kept going with the code, it would take a long time, but I would get a spiral. because you can see that there's not a real pattern here. It looks like there's a pattern, but this number, this 10, 20, 30 is changing. It's changing by the same amount each time. It's changing by 10 each time, but the number is not the same in every line, in every iteration, so it's hard for me to use a loop. But if we use a loop with a variable, we can make this code much shorter. So we're going to set up a variable, and we're going to call this variable something that makes sense. So since we're drawing lines, and this is how long the lines are, let's name this variable length. And the first thing we're going to do is we're going to set the variable so it has some meaning. Otherwise, it's just a garbage number in there. So I'm going to set the variable length to 10 because that's how I start. And then I'm going to choose to write out my code, but instead of writing move 10, I'm going to put this in a repeat loop this time. And instead of writing move 10, I'm just going to choose move however long length is. And since length is 10 the first time through, it'll start with 10. Okay. And then I can turn to the right like I normally do. And let's have a look at what this code will do right now. So this is a very common mistake that my students make. They write this code and then they're really surprised that they don't get the spiral. They just get the same square drawn on top of itself all the time because my length is always 10 and it's not working out the way I want it to be. It's not working out the way I want it to. And it's because the length never changed. It's always 10. It stays set at 10. So what I need to do is I actually need to add a line of code at the bottom here. The line of code that I need to add will change the length by 10. That's not the same as setting the length to 10. By changing the length by 10, you're going to get 10, then 20, then 30. I actually dropped a G there, so that my code wouldn't run there, but you know how to spell length. So the first time it would be 10, then I'd change length by 10, now the length would be 20, so it draws a line that's 20. Then it would be 30 because it's changing each time. And the nice thing here is instead of having to write two new lines of code each time, all I got to do is change the number on my repeat and I can make this spiral as big as I'd like it to be. Now let's have a look at how we can use variables in code.org. So this is the same one I use for functions. So you can see I've added a couple of functions here. We're drawing grass right now. And you can see that there's a ton of numbers in all this code. Number. These numbers are not variables. You can see that there's no names here. They're just numbers. And the benefit of having a variable is your code could remember what's going on from one part to another. And it's going to make things a lot easier. It's going to help me improve and shorten my code so that I can make it look a lot smoother. I can do more interesting things. But right now I'm just going to try and concentrate on making this code shorter and making it make a little bit more sense. And I'm not going to actually change a whole lot. So you can see that these numbers here, I'm going to want to be able to keep track of what's going on. So the number that I want to keep track of are going to be here in variables. So you can see there's a whole bunch already built in to the artist, and you can see that there's one that I added when I made my my function where it says y value at the end there. That's one I added. So I'm going to just grab a function that says set to I. That's not the variable I want. So I'm going to rename this variable. I'm going to give it a new name. What I want to keep track of is the height. I want to keep track of where I am on the drawing as I work my way down. So I'm going to set my height right at the beginning. I always want to initialize my variable. I'm going to go to math and grab a number block. And you can see that my first height is 200 because you see it says jump to 5 over and 200 down. So that means my y value is 200 measured from the top. That's how it works in code.org in the artist levels. So I set my height to that. I'm not using it yet. I'm just keeping track. So what I'm going to do is I'm going to go through and I'm going to set my height every time I move down a level. So I set my height to 265, and then when I go to move down, instead of using 265, I'm going to replace it with height. So since the height is 265, I'm going to use 265 there. And so I'm just going to go and do this all the way down. I'm going to, every time I'm going to use this number in my y value for move down, I'm going to use height, and I'm going to put that right after I set it to that new number. And this seems a little silly right now, but you'll see why this might be beneficial a little bit later on. But as long as at any point in my code, my height is the row that I want to be on, then I can use that number in different ways. So that's what I'm doing right now. So here's where I identified an actual little flaw in my code. you can see that I jumped to a number, and then without doing anything else, I jumped to another number. So actually, I think that jump to 0 over and 328 down, that's an old bit of code that's not actually doing anything, but I haven't taken that out yet. So now here's where the real magic happens. So now, in addition to using my height, what I can do is every time I use my height, I can set it to the height plus go down 16. Instead of having to jump backwards a certain amount and then turn right by 90 and then jump forward by 16 and then turn back left, I can just use my move down function and move down height plus 16. So that way I go down 16 more. But you'll see that it didn't work. You can see it only worked after the first one. So what I realized was that the height's not updating. So actually what I want to do is I don't want to move down height plus 16 to height plus 16 each time. I want to set my height each time to what the height was plus 16 more. So by setting my height to height plus 16, what I'm really doing is changing my height by 16. So if I change my height by 16, whatever my height was, I add 16 to it, and then I move to that height. And that is going to get me to fill in my grass. So you can see my 4 grasses have gotten a lot shorter. That code has gotten a lot shorter. And there's going to be one other big thing I can do here, because you can see my sidewalks always kind of look the same. See how there are 2 rows of gray squares and there's a jump down in the middle? But because they're in different spots, I couldn't recreate them because the Y values were different. Because otherwise I couldn't reuse them, because you can see right in the middle it jumps down to a certain number. So what I'm going to do instead now is I'm going to make a new function, and this function is going to be about sidewalks. And I'm just reusing my code from before, but instead of going to a certain number, I'm going to move down, and because I know I'm keeping track of my height, what I can do is I can use my height variable and do a little bit of math with it. I'm going to set my variable to the height plus, I think it was 10 in this case. So yeah, let's use 10. By doing it this way, what I'm allowing myself to do is I can reuse this sidewalk code for both sidewalks, because instead of having to go to a certain height, I can just go down 10 from wherever I was and do another row of squares. So as long as I get everything set right, this should work out fine. So now when I have these sidewalks, I can just replace them with one green block that says sidewalk. So this whole chunk of code here that's quite long is going to be replaced with sidewalk, which makes my code so much easier to read. And you can see the sidewalk works perfectly. The comments are really nice because this is where I can see where to cut things off. So I just take all that code and it's gone, because now it's all enclosed in sidewalk. And here I finally get rid of this one. Let's get rid of that extra piece of code I don't need. And now, see my next comment where it says sidewalk, all I have to do is keep where I set my height. So I put the sidewalk in the right spot, and then just call sidewalk again. But there's a mistake here, and I don't know where it was, but it looks like my sidewalk's a little too low. So maybe I added an extra 10 here, and I didn't mean to. So let's back it up to 358. That looks right. So now you can see my whole code almost fits on one screen, and it's a lot clearer. And then the reason it's a lot clearer is because I've used a variable and I've been able to keep track of my height as I went.